Good day. Today I want to look into a special limit that is something that we saw very briefly when we were looking at the derivative of sine, but it is an important limit because it opens the doors for us to evaluate other limits. So let me show you what I'm talking about. We have the limit as u approaches 0 of sine of u over u. And we talked about how this limit was equal to 1. We didn't use the variable u. We either used x or h. It doesn't really matter. We're going to use u here because we're not always going to be evaluating this at x. We're going to be looking at signs of other things. But basically, this is a limit that we can check with the table of values if you so desire. But this is a limit that we can use in a sort of modified way to evaluate other limits that involve sine. Let me show you an example. Let's consider the limit as x approaches 0 of sine of 7x all over 4x. All right. We cannot use direct substitution with this limit because if we plug in 0 in the denominator, we have a denominator equal to 0, and that's undefined. And we haven't covered any algebraic means for dealing with limits with trigonometric functions like this. So instead, what we're going to do is we're going to rewrite this, and we're going to deal with it by multiplying the top and bottom by 7. So we've got the limit as x approaches 0 of sine of 7x all over 4x. We're going to multiply the top and bottom by 7, right? We're allowed to do that. We can always multiply by any creative version of 1, and 7 over 7 is 1. Now, what we're going to do is we're going to rearrange things in the denominator. So I'm going to take this sine of 7x, and we've still got that 7 in the numerator, but I'm going to replace the 7 and the 4 in the denominator. The reason that I'm doing that is because now we've got sine of something over that same something, and we can make a substitution here. If we let u equal 7x, then we can rewrite this fraction as sine of u over u, and this is still times 7/4. Now the original limit was looking at x approaching 0, but if u equals 7x and x approaches 0, then u is also going to approach 0. So this limit, now that we're looking at it in terms of u, is going to be as u approaches 0. And we know that when we have the limit of something times a constant, we can bring that constant out front. So this is just 7/4 times the limit as u approaches 0 of sine of u over u. And we've seen that this limit is equal to 1. So we've got 7/4 times 1, which is just equal to 7/4. Basically, when we're dealing with a limit that has sine of something with an x in it over something else with an x in it, we want to find a way to rewrite it so that we've got sine of that thing over the same thing. And we can make a substitution. We can replace it with u, so it's sine u over u, and we know that that limit is equal to 1. Now, we can use this trick when we're looking at other limits where it might not be immediately obvious that this trick is appropriate. Let's evaluate the limit as x approaches 0 of x times cotangent of x. Now, we can't use direct substitution here because cotangent of 0 is undefined, so we need to do something else. And what we want to do is we want to rewrite cotangent so that it is something that we can work with maybe a little bit more easily. So we know that cotangent is going to be cosine over sine. And this is being multiplied by x. I'm just going to put the x in the numerator. Makes things a little bit easier. And what we can do here is we can take this function and we can divide the numerator and the denominator by x, which is effectively going to move that x into the denominator, but in an interesting way. If we divide the top and bottom by x, that's going to leave us with cosine x in the numerator, and then the denominator is going to be sine of x over x. Now, we know that when we have the limit of a quotient, we can rewrite that as the quotient of the limits, so long as those limits exist. And the limit in the denominator is not equal to 0, because we can't divide by 0. All right. And so at this point, we can evaluate these limits separately. Now, because cosine x is a continuous function, the limit of cosine of x as x approaches 0 is just cosine of 0, which is 1. And we already know that the limit of sine of x over x as x approaches 0 is 1. So we end up with 1 over 1, which equals 1. This is just a tool that we can use to evaluate various trigonometric limits. It's a tool that we want to add to our tool belt. We just need to make sure that whatever expression we have, we can rewrite it so that we either have a limit of sine of x over x, or a limit of sine of u over u as x or u approaches 0. We need to get things in that form, and we've got several example problems that we can go through to see the different ways that we might encounter this.